Testing, testing, testing. Welcome to a fun day of lecture. What is it, Thursday? This week has flown by for me. How about you guys? Right? How's it going with Tiny App? It's still yeah, not as tiny as you thought in some cases. Um, Hopefully you're enjoying it, working on your first web application here at Lighthouse anyway. So yesterday I believe you had some readings on cookies, right? Is everybody feeling caught up or kind of like half a day behind sort of thing? Caught up? Nice. Pretty cool. Not always the case. Don't sweat it if you're not. Um, Today, we're going to be talking about a lot of things, actually. I'm going to try and figure out ways to shorten this lecture. I usually go over time on this one. I want to finish by 11. That's my target. Usually it goes till 11:15, so that's what I'm trying to curb here. There's just quite a bit of stuff to talk about when it comes to cookies. I can definitely go through quickly and do it in the way that you'd probably find online or in many other courses, which is to introduce cookies, talk about what they are, what problem they solve, and move on. But I find that in doing that, and we've done that before, oftentimes students have a improper mental model of what cookies actually are solving as a problem, and also even sometimes how they're solving it. So I like to actually take the first bit a little bit slow and actually understand the problem first. Second, come up with an alternative solution without cookies, as you'll see in my agenda, so that we can appreciate where cookies actually help. Because with the improper solution, we'll understand the pros and cons, and then apply cookies and then revisit those pros and cons, right? And so that's my goal. There is obviously coding here as per my usual lecture style. I have a language switcher demo, so what we'll do is we'll implement a small little Node app that's already kind of half written, but we want the user to be able to switch between English and French. That's what we'll implement, either before or after the break. It really depends on our pace early on. Cool? As you know, my lecture style, it's very much about problem solving and thinking together and understanding those things versus trying to get everything that's on my agenda done, right? If we spend less time on the user authentication demo, or we don't get to this part here, security implications, they'll be in my notes as well, and you'll be covering them in the day anyway, so I'm not stressed about that, right? It's more about the approach. How's everybody feeling energized and kind of ready to talk about cookies? I should have brought in cookies. That would have been a fun little thing to start with. Now I've said it, and now you guys are like, didn't bring in cookies. Like, already this lecture is downhill. Great, KV, great. Um, okay, so first, before we go into that stuff, let's talk about HTTP and statelessness. We've mentioned, hopefully earlier this week and in readings, that HTTP is stateless. What does that mean? What does state mean? Let's ask that question more importantly first. What is state? Forgetting HTTP, forgetting network protocol. When we say software has state, what do we really mean? What do we mean by state in software? I'm expecting to see the same hands go up that I normally do, and I'm going to be okay with that at first, and then I'm going to start picking on people. Yep. B-A-N-A, Bana, right? Nice. Okay.
I'm not really sure, but I think that maybe it keeps track of some statuses of the user's entry.
So your answer is some statuses of the user, perhaps?
Yeah.
It's a specific, too specific of an answer, but you're on the right track. It's not necessarily, doesn't have to be about the user. In many cases, it is. So fair that you went there. But in short, can somebody give me a one-word answer on what state is? One-word answer. State equals this. Yep. Persistence is a great answer. State equals persistence. So remembering, is that what persists? Like it persists in our memory? Another one I like to use is state is really memory. Being able to remember something is state. Right? I remember that I'm standing. It's important. And so that's really, to me, especially in the context of HTTP, something that we ought to just keep in mind. So when we say HTTP is statelessness, or is stateless, what do we mean by this? We mean that the server has no memory, right? And this is where the user stuff starts becoming more specific. So the user has no memory of the client. So the server has no memory of the client, I should say. The server has no memory of the client. The other way I like to say this is the server has amnesia. I can relate to that a little bit these days, you know. Tough time remembering names, those types of things. Maybe I have statelessness. Yeah, so it's kind of like the analogy I like to use here is, you know, a browser or a user, as you were saying, goes into a store, being the server, or the person working at the store, maybe a convenience store. Oh, have you guys seen the show Kim's Convenience on Netflix? So good, right? Those of you who have seen it. Those of you who haven't, put it on your list for after you graduate. Not right now. Kim's Convenience, shot in Toronto. I know the intersection, used to live in that or work in that area. Yeah, it's nice show. Anyway, you walk into Kim's store, and you've been there many times, and yet Kim says to you, "Who are you?" and "How can I help you?" Right? They have no recollection of who you are. That is essentially what happens with HTTP. So why is it that a protocol like HTTP was created on top of a persistent stateful protocol where we could have implemented it to have memory? Why was it implemented this way? Why did we strip away some of the niceties of TCP, which is what HTTP is using underneath? And why does HTTP have amnesia? Yep. More efficient and less complex is the other thing. Space on the server is a part of it for sure, like memory takes up space, right? But really what we want is to be able to have transactions. We don't want a long-running connection. Like when I'm playing a video game, maybe a multiplayer video game, there is one connection. We're not using HTTP. We're using the underlying layer of TCP, a long-running phone call, essentially, between the client, the gamer, and the server. because there's just so much stuff happening and we want to keep that open as long as I'm playing that game, that multiplayer game. With the web, we're accessing websites and switching pages, and we're switching off pretty quickly, right? So we don't need a long running, and how long is it going to run, right? Like, how long am I going to use this website? Don't know. And so the idea is that there's just quick bursts of requests and responses. So it's very transactional and very like temporal. Like, I just need this now. I may need this a year from now. Can't keep that connection open for a year, right? And so for that reason, it's been kind of simplified and being more transactional. And in being more transactional, how do we remember what happened a year ago? Oh, like we don't have the whole connection open. The phone call isn't going on for a year, to use another analogy. And so we're going to have to use something else, right? Yep. Yeah, more efficient and safer is not a bad addition to that as well, right? I like that. Anything else before I move on? Any questions so far? So this is not new information. I assume this is more of a review. Yes? Just perhaps a slightly different way of viewing it. So as you may already know from your readings, a way of solving this is setting and fetching cookies, using cookies, which are additionally added into HTTP to help us with the state problem, with the amnesia problem. But we won't actually talk about that just yet. I want to pretend that cookies don't exist in HTTP. Okay? And I want to solve this problem. Or I want you to solve it, potentially. It's not necessarily something that will come to you right away. Maybe what I'll do is I'll write out kind of what would happen if we're not using our kind of crappy solution that we're going to invent, or cookies, if someone tries to log in. And log in is just the common example of remembering state, who's logged in, right? But there's many others. For example, we're going to be doing the language switcher demo before the other one. So really what happens is user visits, let's say, some secret page. Server redirects user to /login, right? Hey, you got to log in. You're not logged in. User fills out correct credentials, right? And submits via post. If at any point, if you're like, I didn't know that was part of the flow, feel free to interrupt and ask questions. What would happen at this point? Server would want to validate those credentials, right? And since in this case, it's the example where nothing is really done in terms of remembering, and we're kind of wanting to see what happens if the server does have amnesia, and we're not doing anything about it. The server, once it validates, validates credentials and fetches the user from the database. Could be like an object or whatever, right? In our case, something simple. And then the server redirects. It just basically says, okay, I have the user. This person is logged in, or this person is a valid, that has valid access. Redirects them to the secret page, right? And then, then the server's confused now because it has amnesia, right? Basically, that person exited Kim's Convenience and walked back in without any kind of short-term memory loss. Oh, have you guys seen the movie Memento? Some of you have. If not, write it down. Important notes, okay? Write that one down. Great movie. Someone has amnesia. Who's it? Guy Ritchie, I believe, right? Great actor. Oh, Dory from Finding Nemo, absolutely. Great amnesia examples, pop culture references. So server redirects them to secret page without doing anything else. Server confused because doesn't recognize user, right? Again. And server, so repeat step 1, right? Or step 2. Is that really what happens? That seems right, right? Not ideal. So what we need to do is do something, my guess is, before step 5, right after step 4. Right? But we're not going to use cookies. How would don't worry about the problems that come up with your solution. How would we working within the limitations of not being able to store something on the server about that particular transaction that could happen next or a year from now, how do we get the user to tell us that they're logged in? Yeah. So remind me your name? Nick is saying maybe on the server side in Express we set a variable to true. Like maybe for each of these objects, one of the things is like logged in false, that sort of thing. And then you set that to true for that user. But then, or are you saying like a global variable logged in? Because I have many different users, so how will I use a global variable? I'll need many variable states, right? So that's why I guess I'm putting it in the object here for each user, right? But even this, you'll find doesn't work. Does anybody want to talk about what the problem with this is? Yeah. Right? Like a user is different than a particular person as a client trying to be that user. So what does it mean for a user to be logged in? Right? If two people, if you log in with those credentials, how do I even look up your logged in state again and the next request? Forget even two people. When you get redirected to the secret page, I need to look up your logged in state. I don't know who you are. I literally have no way to look you up in the database. So what I need to solve is, how do I look you up in the database? I need that username to somehow be in my head as somebody who has amnesia. Yeah.
So if we were only using, if we only had one user and it was a really inefficient website,
Yeah, yeah.
couldn't we require our database into the next page?
So a great question from, I forget your name, Kira. If it's just one user, let's use the extreme example just to see if it works for that. That's a good exercise. If it's just one user, can't we just require a database for the next request? But the thing is, we have a database, let's say, outside, right? And then our app.get and app.post and all of that. That's the server running and has some memory, right? But it doesn't have memory of the specific users that are accessing it, right? And that's the issue. So how would you, if it's just one user, even with one user, multiple people can log in as that user though, right?
Yeah.
So again, you have the same problem with the logged in variable, I think, where, okay, so you logged in as that one user. But now, can I go to the site? What happens when I go to the site? There's only one user, so am I also logged in? Because it just assumes everybody's logged in now? Yep, so you've got the user from the database, right? And so now you know their username, their password, their first name, last name, their date of birth, whatever you have. Yeah. Well, so then I think what you're describing is like just always ask for the credentials because you always have amnesia, right? No? Maybe? Think about, okay, so the analogy I'd like to draw here before do you want to take a stab first? Yeah?
I was just thinking like maybe add to that like a query for the IP address.
IP address is commonly what I hear as a potential response here. It's a good thought. Can someone tell me why IP address? I'm glad somebody said IP address because it's a good talking point. Can somebody tell me why IP address for identifying who logged, like whether that's a person, you know, using that as the, oh, this person is logged in or not, why that wouldn't work? Yeah. Terrible day of remembering names. Multiple users on one IP, but IP addresses are supposed to identify a unique machine. It won't, because there's a difference between public IP and private IP. If you check your IP right now and compare it with your peers in the classroom, you'll have the same public IP, but a different private IP. But when we are accessing public servers, they don't see our private IP, they see our public IP. So we're all behind the same network. And at IBM, a lot of their employees are thousands of people are behind the same IP address, right? Or a big company like that. Or if we're even on a cell tower, right? We're on 3G, we're on a specific cell tower, we're probably sharing our public IP with a bunch of people in that area. So it doesn't really help us uniquely identify. But it's a good talking point. The analogy I like to use to help give people hints here is something like YMCA or another gym. Okay? How do they solve the problem? Because they have the problem of too many people to remember, and they have different people working there, right? And when you walk up to them, how do they look you up in the database to make sure that that gate can unlock for you, so you can walk into the gym? You have a membership card. So it's not that they have a database of users, right? They have their database of long-term persistence and long-term state. What they really need to know is who are you, and they don't remember that even maybe 5 minutes after you left, right? Because the shift could have changed, right? So who's responsible for remembering who the person is? Who's carrying that state? It's actually not the store or the gym. It's actually the user. The user constantly, if they want to get back into the secret or secure location of the gym itself, which is members only, they have to present that card and tap it, right? And that card doesn't have all the information, I bet. It's just that some kind of a unique, maybe their username equivalent, right, is on their card. The machine says, oh, KV. Okay, let me show up KV's face and information to the user, to the person at the front, and then it will automatically unlock KV, right? And so who's constantly bringing that back? It's actually the client. So we have to solve the problem in a similar way. We have to put that variable, as you were saying, not on the server, but they have to bring it back to us sometime. So how can we make the user bring it back to us after they log in? Without cookies, because cookies, yes, they solve that problem, but I want to solve it without. Well, what do we have with HTTP? What are some of the elements that we have to play with? What are the things that make up an HTTP request? The request and response. And as part of the request, because we're talking about somebody walking into the door and requesting access to the gym, so as part of the request, what are the important things in HTTP? Headers, but which headers are the most important? No, those are just optional. What makes an HTTP request? There are two things that you need to make a successful HTTP request. Client and server, yeah, but the client needs to, within the request, send, as part of the HTTP headers. So, yeah. How is a GET request made? First of all, I gave you one answer. There's two important things is get or post or whatever. You need the verb. How are you wanting to access a particular resource? And then what is the resource? / profile. That's the other part of the thing that's really important, right? Those are the two things. Can we embed information in the first one? Get, post? Not really. Can we embed information in the second one? Because they're coming back to us when we redirect them. We're saying, please come back here, right? The step here, number 5. Redirects them to secret page. What it would look like is, in the response would say, please go back to / profile, right? That's the secret page. That's in the response header. So perhaps it can say, oh, and please bring back your ID card, right? Because I need to issue you a temporary guest pass or something, so that I remember who you are when you come back in. Because constantly people are exiting and entering this YMCA, right? Because this is transactional. And they don't have any memory of that, right? And so saying, okay, yeah, by the way, please bring this ID card back with you. And then if you do that, I'm going to check for that in my request.params. So really what we're changing this to is secret page with a URL query string parameter, it's called. A query string parameter. It's in the path. Or you can call it a path parameter, I don't know. It's with the question mark, right? Does this look familiar when you're looking at URLs in your address bar? So now the server is no longer confused. That's a strike through, I believe. the server receives the request and checks for username in request.params.username and tries to look and successfully, this is only the success case, looks up the user in the database, right? So there's a username now of KV and a bunch of other information that they have locally, or sorry, they have for that request. And then they can, the server can say, oh, yeah, you're KV, so server displays the secret KV info to KV, right? I see some people confused about this, so ask away. Yep. Where is password going? Good question. I mean, you should just generally be perplexed by this solution, but just know that you can make it work like this. Do we at least agree that without password, I can look up a username in a database? Yes, right? Assuming it's an object, even the key might be the username, and it's very easy, like users, square brackets, username, gets me that user object. Yes, password's in there, but they didn't supply the password. You're perplexed, and you should be about security implications there, right? But we would be able to successfully fetch the user by their username from the URL and would be able to show them their details. The biggest problem, though, as I hinted, is what? Let's talk about problems here before we get to solving it with cookies and seeing how those problems are solved. So what problems arise with this? Yep. Yeah, now it's just a matter, it's a huge security vulnerability where the URL contains the ability to log in without having to even go through a login process. What was the whole point of putting in my password when ultimately, if I just say username equals DB, I could try and log in as Don Burks or whoever DB is for that website. I have to do nothing else, right? So URL contains the ability to log in, which means that anyone can guess, easily guess, or I would say not even just guess, impersonate someone else by guessing, right? Other problems that arise. So there's a security problem on number 2, but there's other problems that arise as well, even with that security problem not there. Same thing, right? We've got the thing in the URL. Think about what else could go wrong here. Someone else, not Banna. What else could go wrong here? Think about what you do with URLs that are in your address bar these days in the modern web. What do? We share them, right? That's going to be a problem. User can accidentally share or intentionally share their, not only like a particular page, but also their login state, right? That they're actually giving away their YMCA card as they're telling them to which YMCA to go to, all in one shot, right? And there's potentially one more. While you're thinking about one more, I'm just going to clarify this one here. This is the problem with number 1, right? It's in the URL. It's easy to see. It doesn't even require guesswork. I can just quickly look at your Facebook and see, oh, you're on /profile, user equals whatever, and I can just copy that and log in as you. That would be brutal, right? And so that's the problem with number 1. Number 4, can anybody think about that? It's a little bit more obscure, but it's going to be a problem. Banna?
The memory problem, that how many users can you keep track of on the same domain?
That's a different problem. So how many users you can keep track of on the domain. So imagine now I have a /profile app.get. And in that, I have the ability to check the parameter username, which comes in through that question mark username. And multiple people can be accessing this particular page. And one of the things I do is I fetch the user based on that username. So you could be coming in, I could be, right, and so on. And that's okay because it's transactional for you as it is for me, right? And so as long as you're identifying yourself with your username and I'm identifying myself with my username, the server doesn't care. It can handle hundreds or thousands of different users as long as they're in the database. So that's not really a problem necessarily with this solution. In fact, that's not really a problem because of how HTTP is stateless and allows for that same URL to be used by hundreds of different people, thousands of different people, as long as they can be uniquely identified or identify themselves. Right? They all bring their different guest passes in, right? And so that's okay. Hand in the back, name? Benita, yep. Yep. That's definitely part of number 2, right? The fact that you can impersonate one person means you can just write a script to impersonate as many people and just try to brute force and guess a whole bunch of different usernames and see what comes back. Yeah, that's a huge security hole, but that speaks to number 2 already. Good point, though. What happens when you, we want to be able to be logged in longer term, right? How long should we be logged in for? At least like, what's the standard? Like, I don't know, months, weeks, right? Definitely not what'll happen here. What'll happen here? How long will I be logged in for? As long as I'm on the page. What happens if I close that tab and go back to the website? Am I logged in? It's in the URL. I've lost the URL. Unless I specifically type in question mark username equals KV. If I just go to the home page, it's going to be like, who are you? Right? And so the other part is closing the tab means losing that state since it's in the address bar of that tab. That's the only place that state is in the address bar for that tab. Do we agree? Are you guys still with me on this?
Isn't it just like part of your history though? Like scroll down, I know what you mean. Like you're logged out as soon as the browser closes. But it is like easy.
Yeah, I guess through the address like history. Now modern browsers have history. So like I guess as I'm typing in the URL, I'll see question mark username equals KV. Another security problem right there if somebody else is using my computer, right? So many problems security-wise that we'll just say, we'll just blanket under number 2. But yes, that feature would allow us to quickly press like down and enter and get to that website with a login state. But like, still kind of, you have to make that step. If you're just going to just going to the root page and just, doing that, you're not logged in. It's a fair point though. Yep.
At this point, if this was to work, or someone was to actually implement it, you would only have the login page where you put your credentials and then you get assigned your URL. And then everything else on that website would have to post from, like, append to.
Yeah, that's the other point actually. Yeah, that's the other point. Issue number 5 is now your EJS has to constantly, whenever there's an A tag, all internal links have to append question mark username equals username, right? In the anchor tag with the href, if I have /friends, it's going to have to be /friends question mark username equals KV because it has to remember me with every request because it's like I'm exiting and re-entering that YMCA every time I want to make a request, right? And so this is another developer kind of headache that I have to put this if statement or this kind of logic into each A tag, into each anchor tag. Absolutely. So that's actually a 5th problem that I've forgotten about. Good point. Cool. So that's tackling the problems with this approach. But the important takeaway here is that it can be remembering state with each request can be solved. It's just that for this particular example, it's a security issue, right? But this is an implementation that is used for other types of non-sensitive state memory to be able to remember some things, as we'll see soon. So just remember why I said that. This solution It's not a bad solution in all cases. We've seen it, right? We see the question mark thing being used, right? And so perhaps it is useful for other less sensitive, you're not giving access to everything, but you're maybe just switching a few things around based on that user, something like that. Where it doesn't matter if they try to impersonate or something like that, or try to guess it. But for something like being able to access your personal information, not ideal. Right? You guys with me on this stuff so far? Okay. Now we're going to examine cookies. All right? And cookies are apparently the solution to this particular class of problem. And we'll see if that's true or not, and to what extent, by having listed all those problems separately. So first of all, someone else explained to me how cookies work differently. They solve the same problem of the user being able to tell us who they are, because we can't remember, but without putting it in the URL. So tell me, kind of, either technically or non-technically, how cookies solve this problem using 1 or 2 sentences. No one?
Non-technically, remember it's who you are,
Who you are for every page. Here's what we notice about sites that use cookies, okay? They don't do this, right? They don't have the username in the URL, for example, right? But like, this is kind of the outcome, right? How is it actually accomplished using cookies? Go ahead. You send them with every request. Because we can't escape that problem, can we? That's why we had to put it in the URL. Can't escape that we have amnesia, we the server, have amnesia, and require each client to carry something with them to bring back to us with each entry / request. Agreed? Can't escape that. No, we tried to put it in the URL. We saw a whole bunch of problems with that, right? And so are you suggesting that you don't put it in the URL but put it elsewhere, but you still have to put it somewhere? So where? How do you deal with that? In the request, but not in the URL. Right. Therefore, the unique identifier, so in this case username equals KV, goes not in the URL, but in another part of the request. Someplace, what? Someplace. First, we need to solve the problem of, like, if I close the tab and I reopen that tab without the URL doesn't contain the information, so I still want to be logged in. So it has to be sent up again. So it actually has to be remembered by the user. Now they're not carrying a guest pass, they're actually carrying a long-term pass, right? It's not just for the day or for that one visit. It's their membership, right? And so someplace longer term. And so what the agreement between HTTP servers and clients for cookies is that the client will implement some kind of storage locally to remember data long term. You know how you can clear cookies in your browser? That's because browsers store the cookies locally in some place on your hard drive. Right? URLs don't have that, right? URLs are not going to, I mean, I guess there's history, but not really, right, aside from history. So someplace longer term in the browser. The other thing is to not include them in the URL. So they are transmitted with each request, just like the URL is with each request, but not and stored in the, or rather through the headers, not the URL directly. Right? As we'll see when we get to our little demo. Shouldn't call these demos because it's more of an exercise. So far, so good on this? Do we agree? Like, does that, at least from a theoretical standpoint, make sense that, okay, this is what we'd have to do. We'd have to not have it in the URL. And because tabs can be closed and reopened, you'd want them to like save it in the browser, right? Just like putting that card in our pocket and using it next time, right? The browser is our wallet in this analogy. Agreed? It's doing that. We can tell it to clear, and we can purge that wallet by clearing the cookies. Who does that nowadays anyway, right? Isn't that crazy that like Chrome, one of the things they implemented about 6 months ago, it was kind of a big deal, but then we just kind of forgot about it. When you clear your cookies in Chrome now, it doesn't clear all your cookies. It doesn't clear your Google cookies. Yeah, you're still logged into your Google account after you clear your cookies. Talk about taking over the web. Anyway, I digress. In terms of the data that's actually stored within the cookies, it's exactly the same format. It's key value pairs. You can have one, and you can have more. You know, you just have ampersand in there to separate them. I'm just looking at my agenda here and the time. So 9:42. I think it's a good time to take a break before we switch to writing some of the code that makes this tick. We'll implement a cookie-based solution, not a URL-based solution, using the language switching kind of problem, being able to switch languages on a website. We'll use cookies for that. Cool? I'll see you back here in 7 minutes at 50 after. Where did I say that?
No, it was on here. It's like what we said expressive variable.
Oh, the. All right, let's resume. So we left off talking about cookies kind of theoretically and what problem we ought to solve. And we maybe even should come back to these problems and just see, which of these are actually solved by cookies or not, but we'll do that after the language switcher exercise. So what I have kind of already as boilerplate code is some stuff on the screen that you're going to read quickly. It's an Express app, what you're comfortable with. It doesn't have much, right? It just has what looks like a home or a slash route, like a root route. And it just renders welcome right now. So we have some implementation to do. So what does welcome look like? Welcome. You can imagine it being a home page. Maybe there's some news articles or something on it. And then it has like in the nav bar, which language would you like to choose? In this case, it's not assuming anything, or maybe it is, it's assuming English, but it allows you to switch between, right? And the idea is that once you click one of these links, which have yet to be implemented, that it should stick. It should remember. Again, that state thing, right? And so that's where the cookies will come in, is to be able to remember that stuff, right? So let's see what this looks like if we were to run it. We can go to localhost 8000, and indeed we see the site. These buttons, or these links rather, are not linked. They're just going to pound. And we do have two other templates, English and French, home pages. These are home pages. These are not supposed to be /English/French. So the idea is that once you click English or click French, that you get taken back to the home page. But this time, the home page is smart enough to not show welcome, but show the English version without even the choice up there. This essentially is the user experience we're going with. It may not be don't worry about it being the ideal user experience. It's just a demo, right? Not necessarily super practical. So in terms of implementation, how can I work on this in a ideally incremental fashion, right? As I'm learning and developing stuff I'm less familiar with, I should be even more cognizant of working incrementally. So I've got the server up. I've got my file open. There's not that many files here. And I've got, it's kind of doing its thing. So the first question is, how will we actually switch the language? And how will we remember? Right? Because you might be inclined to say, well, we'll just make the route go to, where's the route on welcome? We'll just make it go to /English as an example, and /French. And as an example, this will just render English. But we have to pretend that this is a solution for something this small, sure. It doesn't require cookies or anything. You're just taking them to the English version of the site. But we have to pretend there's thousands of pages on this site, and we want to just remember that they selected English, and then no matter which article they go to, it's going to be the English version, right? So just going to the English homepage doesn't really help with that. So what can I do? What should be my path to my solution? I'm going to have to use cookies because I'm going to have to remind myself which language they selected once they select one. And how do I remind myself? Well, I can't just put variables on the server because I have thousands of users. I'm going to have thousands of variables, and even then, how do I know which user it belongs to? I can't do IP address. So I'm going to use cookies, right? URLs could be another solution. Right? Instead, I'm going to use cookies because that's what this lecture is about. And then what that's really saying is it's actually like deferring the responsibility to the browser. to the user to send us back which language so that we remember which language it was. They're telling us. Right? And so really, when they click on English, ideally it should be a post, not a get, because they're actually saying, I want to switch my state to English. Right? Ideally it's a state change. Therefore it should be a post, just like logging in would be a post. Okay? We're going to actually not focus on that. We can just write down a to-do or a fix me for later to make this a post. Because we're dealing with A tags, when you click on an A tag, you have no choice but it's a get. Browsers will always make a get. Right? We'll later on look at fixing this or hijacking this with JavaScript when we're doing something later, like next week. But for now, we'll just be like, okay, fine, it should be a post, but whatever, it'll work with a get. We'll deal with it. But we know that that's not the right HTTP paradigm. Okay? And we could say that it should do something like this. It should switch the language to English, not go to the English page, right? I mean, I could make this whatever I want, but that's what my route is going to do. So because I'm working incrementally and following kind of error first approach, I'm going to actually cause the error first, right? So lang en, since this isn't a template, I don't even need to restart my node file. So now when I hover over this, it's lang en, and what I expect is an error because lang en is not a route. And I expect it to be a get request because, as I said, links are gets. So now I'm going to implement that. Right? I'm going to restart my node server. And now when I hit this, I expect to not see the error, but see that message. The question becomes now, that's my error state now. Like, I shouldn't see that message. I should really see something else. What should I see instead? Well, on the server side, it should just remember that I selected English. So that's a cookie. And then it should redirect me back to the home page. Yes? So, because we're setting a cookie, will it be on the request or on the response? The server is giving them the access card that says what their language preference is. Response, because it's the result coming back to the browser, to the user. It's the HTTP response. So in the response headers, we're going to set a cookie using the cookie function that's built into Express. Right? If we're like came across it as documentation, and we're like, ooh, cool. I don't actually know what this is. Feel free to do stuff like this. All right, I'm not going to call cookie. I'm just going to see what cookie actually is. Should be a function, I'm told. Right? Doesn't take that long. Refresh. There it is. Doesn't give us much detail, but it's at least validating what we understand. So instead of send here, we're going to cookie, and according to the documentation, which I won't show right now, you give it the key and value, the username KV thing. Instead, it'll be something like lang or language and English. And then we will redirect to, I mean, we don't have to redirect, but we could just send back hello, but the whole point of this is take them back to the article or whatever they were on, right? Does this make sense so far? So how would I actually, with each step, I should be able to test that step. So what's my test strategy here? That this worked or not worked? Because it will take me back to the home page, which will still just say, welcome English or French, that we haven't changed that logic at all, right? So what am I going to do? Exactly. Check if there's a cookie because a cookie is being set. Do I really need to see if the home page changed? No, I can use DevTools, right? So I'm going to open up DevTools. This is why sometimes it's important to have that plan first, because if I have to open up DevTools to be able to see that kind of happen easily. Let's kind of restart our server here. And let's go back to the home page and click English. How am I going to see the cookie being set? Let's take a look at the network tab first. Okay. I have the kind of the home page here, get, coming back. I click English. I seem to remain on the home page with no real change, so I can't test that way. But what I do see is that there's a get on /lang/en. Came back with a redirect. And the response included a key value pair as a set cookie directive sent back to the browser. The browser ideally is well behaved and says, oh, I got to store this in your cookie jar. Right? I think it's actually called a cookie jar. Seriously. Anyway, so that's our way of validating. Also, if I look into the application under cookies for localhost, I see all the key value pairs, in this case only one, that are assigned to this particular website, localhost 8000. I'm not going to see Facebook's cookies here. I'm only going to see the ones that are for this particular domain. Okay? So that is working. So now what we need to do is, on the home page where we can toggle, we need to render English if the lang is set to en. So we're going to have an if statement, right? Somehow we're going to have a selected lang. And in that case, we're going to render English. Let's call it preferred lang. Otherwise, we'll go to welcome. We'll implement French next. It's, once we have this working, French should be easy. Right? Notice I don't have preferred lang defined. That's okay. Error-driven development. I expect that to be the error. When I refresh welcome, I expect that is not defined. I need to set preferred lang. So we're going to say const preferred lang is equal to. And I'm going to need to get this information because apparently a cookie, what's nice about a cookie is every time a request is made now, in not the response, but in the request from the browser, the cookie will be included. So it's like it's in the URL, except it's not. And we don't have to, as developers, put it in the URL. It's all the browser's responsibility now is to always send it up with each request to that domain, to localhost 8000. Okay? And so we just have to read it now. It's coming up to us. It's in the request. It's in the request, right? It's somewhere in the request. Let's see if it's true. Console.log, the entire request, right? Let's do that. Restart. Yes, we're going to have that error. But before we have the error, we have a console log. Therefore, I expect to see error, but before that, a huge console log because it's the entire incoming request. And somewhere I'm told that there will be a thing called cookie. So even here, I can Command F and type in cookie. See if there's any mention of cookie. Oh, look at that. There's a key value called cookie with a string lang equals en. Right? And so it is indeed there in this crazy large output that represents the request. So far, you guys with me? Great. And so now, I just have to access it. Well, where the hell is it again? Cookie. No, that's not the one. This one. It's under headers. Huh, look at that. That makes sense. It's in the request headers. So I can do request.headers.cookie. Let's just make sure I have the right object.property.property of that object, because there seems to be a nested object here, by just console logging it before we start using it. So I'm going to refresh here. I still see the error, but my console log, look at that. Right? Now, what's annoying about this? Can anybody guess? This is a string. Right? This is just one string. It's like double quotes around this. So I'm going to have to especially if there's multiple values here, I have to split them using the ampersand and then split them again using equal sign. That's a lot of work, and that's something every app has to do. Whenever there's something every app has to do, let's just make a library that does that, right? And publish it so that other people can use it. What is that library? Well, we can parse this ourselves, or we can use cookie parse. Now, I intentionally had that commented out because another misconception that students have is that cookie parser is required in Express to set cookies. You saw that I set cookies fine. You saw that I can read cookies fine. They're part of HTTP's specification. Express will allow us to have that information. It's just that it's not convenient to read them. To write them, no problem. There's that function that we set, right? But to read them, I don't want to get back a string. I just want key value pairs, objects, right? They're great for key value pairs. Just give me an object back. And so this middleware is being registered on line 6 to intercept every request, see if there's any cookies, and break them up into objects. So that using the split and join, or rather just split and creating an object, right? And it's just basically doing a little bit of like looping and creating an object. And then we have access to that. And so because I've enabled that, I now have access to another thing called request.cookies. In other languages or frameworks, sometimes it's called the cookie jar. Sometimes just cookies, plural, same idea. Let's not console log this. Let's console log this now, which is the thing that the middleware gives us, and see what happens. Again, I expect to see the error because I haven't solved that yet. But look at this. Very different than lang equals en. This is now very easy. I can just say cookies.lang, right? Or square brackets lang. Am I going too slow? Are you guys with me? Or is this too slow? It's okay? Okay, just want to make sure pace-wise. So I can just do this then, right? And that becomes my preferred lang. We can console log that out if we want to be extra cautious and confirm our understanding of what we just saw as the output, where cookies was the object with lang as a property. You should take those kind of small steps, right, as you're working on this stuff. Now when I restart this and run this, my expectation is that preferred lang will be en, and we will go into this branch of the if statement and see the English template. I'm going to hit refresh, and indeed, it's not asking me to switch. It's actually showing me English.ejs because that's what I'm rendering. So now I can open up another tab, and when I go to it, because the cookie is still there, it's being transmitted with that request too, right? I could close this tab, and when I refresh this, I'm still on it. I don't have the URL problem. Agreed? It's still being set, and I can see it here in this table. In fact, if I set it to FR, which I can just do here without even any kind of server thing, DevTools gives me that ability because it's my data in my browser. I can change it. Now when I refresh, that if statement is not getting en anymore, it's getting FR, right? And it's going, oh, I guess that's the else condition. It's showing the default welcome page. In case to handle French, not too crazy. We just have to do that, right? Yeah, that's right. Thank you. And now when I refresh, because I've set it to FR, it's going to French. If I set it to EN, hit refresh, it's going to English. Sometimes, by the way, heads up, you see what just happened? It cleared. That's a bug in Chrome that I've seen for a long time. I don't know why they haven't fixed it yet. You just have to hit refresh if you're not sure what you're seeing is what you ought to be seeing. Don't trust this until you hit refresh. If I say something else, that's going to go into the else and be like, I don't know that language. You know, do you want to pick one, right? And then, of course, French, how it would be implemented would be very similar, where it would just be /lang/fr. And in our routes, what would we do? How would I implement lang/fr? Same thing, copy and paste? Or is there a better way? Tell me there's a better way that you can identify based on your limited experience with defining routes in Express. Should I? Yes, I can implement it like this. Feels very repetitive. Is there a better way? If I have 60 languages, am I going to have 60 of these? That sounds not very scalable in terms of maintainability. Can I have just one of these? Make it more dynamic? And just put in that extra thing that we can grab from the URL, right? We're saying any string here is valid, except anything. It could be a number. And then we set it to be that value. Request dot params, I believe it is. Is that right? Dot lang. I'm going to fetch it from the parameters that are sent up. And then we don't need this, because now any language is supported. /lang/anything is acceptable. Now we could have a check in there to be like anything is not a valid value. I don't care. For now, whatever. It'll just not recognize that language, right? In the else condition, no big deal. Depending on what kind of logic you're implementing, you might have to guard here a little bit. So now French should work as well. When I click French, it sets it to FR because lang/FR, and then it takes me to the home page, which then has FR set inside of application. Did all this make sense? Any questions? No questions. I have a question. You ready? It's an important question. Is this a good solution? Should be something you should be asking yourself at hopefully every step. So my question is this a good solution for this problem? The problem being a website having switching languages. Have you seen this solution for website switching languages? Where once you switch the language, it seems to use cookies because then you don't have to set it again and you don't see anything in the URL. Or do you see a different solution for websites that you visit? Yep. Say that again? Yeah, so language specifically, it might be location-based. Actually, your browser sends up preferred language as part of the request. You might have seen it. If we look at the network tab and look at any GET request, let's take a look. Request. It gives a comma-separated list of preferred languages in order. So it's saying, give me English, Canadian. So perhaps the website can actually, by default, be like, oh, here's English, for sure. That still is not answering my question fully, though, but you're right, this would be a part of the solution. This is just more of the, what happens if there is no cookie? I'm going to assume, because you have ES, let's say, that your default is Spanish, and I'll default you to Spanish. That's great for default. But then in terms of when you switch, your accepted language is still going to be the same, because that's what your operating system is set at. You've said that your preferred language is that. That's what the browser will always send up. But let's say you switch now from Spanish to Portuguese, right? Where is that information? Is that in the cookie? Is it in the URL? Because we've explored two different solutions so far. You're saying that most websites use cookies for language switching? We have two ways of storing state, right? In the URL, which is a little bit more work for the developer, less secure. And then we have cookies that kind of do this behind the scenes. And we could use that too. We just did. Which would you use for language, or which do websites use for language? Do they?
I think they put it in the URL because it's not really security risk or anything.
Because there has to be some benefits of the URL too. Otherwise, why would they put it in the URL? Can we go to a site that maybe is multilingual? Could someone give me an example? Except, yeah, maybe like a publication or something a little bit more widely accessed. That would be more international. I guess consulates would be too. Like, you know, maybe like New York Times or something? Yeah? I wonder how they do it. Now, there are two options, so we don't know. English is what it's defaulted to. Where is it? URL. I mean, whether you put it before the question mark or after, it's still request.params, right? It's still part of some dynamic request. So does that mean now that when I go to any particular article, it'll be /es? Now, I will tell you this. There are sites that you can find that will use cookies instead, and they won't put it in the URL. So the question is, which approach is better in the modern world? And why? Maybe I'll focus on the why. I can tell you that websites have transitioned more in the modern web to this, whereas they had cookie-based solutions before. So actually what we just implemented is what's considered today as an unideal implementation for the problem. But I still went ahead and did it. I wanted to see if anybody wanted to comment on it. Why is it that this is a more preferred approach, even though it has all those problems, and people moved away from cookies for specifically language setting, which is a very common thing that we find? Yeah.
When you share your article online,
Nailed it. Yeah. What happened is people started sharing these URLs, and you'd have a Spanish person saying something about an article in Spanish, putting the article in their tweet or whatever, right? And it was cookie-based, so there was no Spanish context in there. What does Twitter do? It expands the article a little bit, shows you the title, the description. Well, Twitter doesn't have Spanish in the URL, so Twitter fetches that URL, and guess what it comes back to Twitter as? English. So all of a sudden you have a Spanish tweet where the metadata on that URL that they shared is in English. Sites are going, oh, yeah, we got to solve that, right? And so what they did was they switched to a better approach. The approach that we said wasn't good for user IDs and usernames is actually a good approach for language switching, specifically because of that problem. Maybe others that I haven't thought of, but that's probably one of the core ones that made websites switch over, was shareability of URLs. Now, of course, people are also sharing an email and stuff like that, but it seemed like websites weren't as cognizant of that problem until they become, the websites became shared on social media, Facebook, Instagram, those types of things. Right? And so you see a transition, especially in the more larger website publications that have the resources to spend. They've switched to this. You spin up a WordPress website that has international support, by default it will base it on languages, right? Not cookies. Was this a worthwhile exercise, even though we did it wrong with language, just to experience kind of that you can implement it with cookies, but here's the more modern approach? Yeah? Let's go back to our problem set. Before we do, maybe you have questions, yeah?
Well, at that point, if it's in the URL like that, I guess as a parameter, do they have a different web page for each version of that language?
Yeah, that's a good question. Like so that article had like a unique URL, like /2019 something 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 some title, but it was prefixed with /es. So what they're actually doing, and it doesn't have to be in Express, you could do this in Rails or any other thing as well. Their app.get for article is /lang /article ID. Or it might be like in their case it's /year /month /day /article ID. Right? And they don't have thousands of these URLs. They just have one, and then it does the fetch from the database. Right? The first thing it'll look at is the lang, because all URLs are not expected to have lang. Or maybe it supports both one with language, and then when it defaults, it has the one without the language. So it supports both types, right?
Because in their database, they wouldn't have that article and as many languages they support. But
yeah, because if I just go directly to an article without en or es, it will still work because of the line 24. But then if I do switch, it'll start using the other route on line 26 for all of them. And in their templates, they will have if there's a lang, add /lang first before the article ID into the link. Pretty cool, right? Nobody's that excited. I'm the only one who's excited by this. The reason I teach it this way is we really have to appreciate what cookies are solving, and that they're not the answer to everything. What are they really solving? They're hiding the information from the URL and putting it elsewhere. That's it. Oh, and it's now being sent with every request as a result. So if I close the tab, I reopen it, it's still being sent up unless I clear my cookies. So let's revisit our agenda here and look at those problems we stated with without cookies. The URL contains the ability to log in because it had username equals KV. Would it have that problem with cookies? Would this problem still be a thing? No, because it's not in the URL anymore. So this is fixed, right? Agreed? Okay. Anyone can easily impersonate someone else by guessing. Well, you know, that meant their username. Solved? This is solved, right? Is it solved? So with my language switcher, I haven't done the other one yet. Can I just start guessing languages? Yep.
When you were online and you were using the dev tools, you were able to switch.
Very good point. I was able to just use the dev tools to switch the language.
So could you just guess? Maybe you could guess on purpose.
Exactly. Exactly. That's why I actually showed you that, because I wanted to see if you applied it here. Right? And if we were using not a browser, because cookies are part of the HTTP specification, if I'm using curl, I can specify the key value. Just keep trying, have a script that loops through and just curls. With, instead of now in the URL, it's in some other argument in my curl, like slash, I don't know what it is, slash h, something like that. Not slash, dash h for the flag, right? And so I can still specify multiple usernames and see what happens, what comes back. And so this is not solved, right? This is a pretty big problem. We said we were going to solve this. And we said the cookies were going to solve these problems for us. This is an important thing. This is that mental model incorrect thing that I was talking about, where students think that cookies solve this problem. They don't. They do not solve the security problem. This is the biggest one here. User can accidentally, intentionally share their access because it's in the URL. Because it's not in the URL, this is solved. It's in your browser. Only your browser has that data. Closing the tab means losing the state. Nope, this is solved because it's not in the URL. You can close the tab. The cookie is still there unless you clear the cookie. All internal links have to append. Solved. Because unless you're doing the language one like we saw with New York Times, yeah, then they have to because it's in the URL. In our case, we're using cookies for, let's say, user IDs. We wouldn't need to worry about modifying the URL in our templates. Agreed? Okay, let's talk about number 2, what was apparently the biggest problem. This is not solved because, as we'll see in my next demo, which is already implemented, so maybe I'll bring that up and we'll talk about it. User authentication demo. Let's bring it up. This is going to be the topic for the next, let's say, 5-10 minutes. And then after that, hopefully we'll have time to talk about other security implications that we haven't talked about yet. Okay. So we're going to go to the user auth, and we're going to run it. I think it's server.js. And I'll open it up as well so we can look at the code. Remember one of the things I said in my previous lecture? Skill of reading code that's already on the screen that you didn't write or you don't remember. We're gonna use that skill here because this is an implemented solution here. So far, this is just boilerplate code. More boilerplate to get it set up with some middleware. We have a fake database just like our URLs database in TinyApp, except it's just the database of users. So it's just an object with some users. The key is the username, and then the value is more than just the username. It's the first name and the password. Very secure passwords. Please don't try logging in as me in sites. I may be using passwords like this. Who knows? And then there's a treasure page, which is supposed to be, like profile or something, some kind of secret treasure, which can only be accessed once you're logged in as someone. Right? And that one is implemented. This is all implemented. I'm not writing any code here, by the way. It's not the best implementation, but it's something. It's the minimum amount of effort, right? So I'm going to let you read that while I sip my tea here. and then see if you have any questions so far. Specifically, you have to understand what line 31 is doing. The rest should be okay. Who is wanting this line explained? 1, 2, 3, 4. Not sure if that's a thing. We'll say a few people. Can someone else explain it? Yeah, first hand.
So, the user only exists, the const user only exists if
Is only defined.
is only defined.
Yeah, otherwise it'll be undefined, right? Yeah.
Is only defined if request.cookies.username is the same with their and.
Nope.
It's not?
No. When you do just a check like this and you do an and after that, what are you doing? Because it's same as equality check, which is triple equals or double equals. Yep. Nick, right? Yep.
Seeing if each value is a falsy value.
Yes, it's falsy value. So is this even there? That's all you're checking to see if this is present, because we can have a cookie set and we cannot have a cookie set. We don't know if that value is actually defined. So we want to make sure it's defined before we use it. It's called a short circuit. Before I use it in the next part of the and, I'm short circuiting. And because I know it can be undefined, right? They cannot have a cookie set. They could be a fresh user, a new visitor. So absolutely, it's a truthy check or a falsy check. And if it is defined, then we will use it in the next part of the and. Can you explain that one? You want to take a stab at that one?
Because then it'll be the user's, it'll check in the user database for that username for the value that.
Yeah. And so what we're expecting in the square brackets is always a string, right?
Yeah.
Because it's object property access. Why did we not use dot notation? Why did we say users dot? Can we use users dot there? Because you can access properties too with square brackets and a string, or with a dot and then the name of the thing, like dot username. Yeah. Huh?
You can, but it'll throw undefined if the rec.cookies.username didn't exist. So if it exists, then we can use the dot, but if it doesn't exist, then this will be.
So how would I use the dot then? In this situation, let's talk about the happy path where it exists. Would I just do dot and then this? Wouldn't that not work actually? Because what is this doing? Users dot request. Well, there is no request property on users. See, what I'm doing here is I'm actually looking up a property by that name. And I can't do this, where I put a string around that. That's not valid in JavaScript. And so actually you can't, even whether it's set or not, you can't do this because this is deliberately going into users, then going into request under users, and then cookies under that, and then username under that. That's not what we're intending. We intend to actually use the value in here, right? But then you might say, okay, well, let's assign that value to a variable, and then just do dot username. Again, same problem. There is no username inside of users. There's just kv and db. So I can do dot kv, or I can do dot db. But in order to access them by string, I need to pass in the string only. This is why square brackets is important. When the value that I'm trying to access via, the property that I want is a dynamic variable. It's not something I can just type in the code. So that's important. So are you guys, this is 2 lines now, but it's doing the same thing. You guys with me on that? Okay. And then if we get that, we find that user from the database, because we couldn't. In 2 situations, there's 2 situations where we wouldn't find the user. What are those 2 situations? The cookie is not set, and we short circuit, and there is no username. Username becomes undefined, right? Or the username is defined in the cookie. It's sent up, but it's like some old user that we've deleted or never existed, that username. And so we just can't find them in the database, right? Those are the 2 situations. And if that's the case, then we'll just be like, no, go back. Like, you need to go to the home page. Or, you can't see the secret treasure page. Otherwise, we will show them the treasure page. And does this look familiar? What is this for? Template vars? I find students often get confused about template vars, maybe because of how we've named them, I'm not sure, maybe because it's, it's different. What we're really doing is we're calling treasure, and treasure is a template, right? It's an EJS template. But what you should see whenever a render is called, it's really just a function call. It's a function. Ultimately, Express needs to send back HTML. And what is HTML? It's a string. We could have a function called render treasure, and it returns the string from HTML to end HTML with the treasure. But instead, putting all that string into JavaScript, we said, nah, let's flip it. Let's put the string inside of a template file, and it can have JavaScript. So it's inverted. Instead of JavaScript having the string, it's a string having some JavaScript. Because we have more of the string than we have more of the HTML than we have of the JavaScript. So we flipped it. But ultimately, we're calling a function called treasure.ejs. And it needs some input, and it's going to return us the string. Right? That's all an EJS template is really doing. It's a function that returns a string, and it's mostly string with some logic in there. Okay. In our case, mostly string, except some embedded logic right here. Yep.
So with our tiny app, I was actually wondering, could we set the template vars as a global variable? So instead of having to call all the data from template vars and all of our routes, we could just say, call.
It's a good question. Can I set my template vars as a global variable? Give it a shot. See what happens. This is the kind of stuff I want you to be doing. Remember, though, that HTTP servers handle requests from many different people. So when you have in your memory a global variable, that is now for everybody. So if that's what you want, then that is the right solution.
So as long as it's accessing, as long as it's still doing comparison to the cookies that I have, it'll go through the database, incorporate information. Or I have to build that functionality into it.
What do you intend to pass in via global variables into template vars?
The username and the user specific.
But the username is not global to everybody. It's not the same for everybody. So as soon as you put it into global, it's now shared across all requests by anybody.
So my question is, can I build a cookie into it, or something that is calling the cookie from that particular route?
This is a common confusion. And so I guess I'm going to take a little bit of time on this, even though we're not talking about cookies per se here. May I? We have our server, and in it is a bunch of app.gets or apps.posts, right? And this is a process that runs. Right? We do a node space, and we start up a process. We can see it on our activity monitor and all of that stuff. And then we have these like app.gets. Let's call this one /treasure /t. Is that okay? Another one /login, and so on. This is an app.get, and let's say this is an app.get, whatever, I don't care. When a request is made by a user, and you have global variables, let's say here, like users. This is outside of these, right? This is shared information that you can use in here or in here. Because all of these may need to see who all the users are, right? To be able to access the right user. So that's why we have a global variable called users. Is that an okay way of drawing that? My whiteboarding skills are not as good as they should be. When a particular HTTP request comes in, it's handled by that callback. And remember, the server has amnesia, and so we have maybe some username equals KV being passed up. And then so we have that available here. It is not available here. What happens is Node will say, oh, here's a request. It will literally consider this a separate process in a way, right? And say, you are dealing with this user. And only you. And that's it. And then you have to respond with a string with some HTML in it. Right? And so if you had a global variable here that you set called, what were you planning? Like username, you said? So username equals KV. Well, yeah, you could set that. Sure. Username is KV because it came in here. But now that's available and readable anywhere. So anywhere I can now say UN, what is UN? And it will say KV. Is that really useful for another user coming in from here? Or even a user coming in to this next time? Not really. Right? I would argue no. It should just come in from that particular user because it's only relevant for that user. Unless you have something else in mind, I didn't understand your question.
That was not my question.
Okay.
The question is, are users, in this case, in the actual database that we're working, and right now it's hard-coded, but we do import users that register. So I was wondering if when we are making our HTTP requests,
Yeah.
if we could, because we need to have our template bars for actually setting up our pages and stuff, I was wondering if we could then, through that process, be able to filter through our users database and then apply it to the template bars.
Yes.
Yeah.
Yeah. So that's not what I understood your question to be, sorry. But still, this was, I think, an important thing to talk about. So in here, then, right, you would use the cookie to access the user.
Yeah.
And then you'd have a local variable called user
Okay.
set to that thing, just like I have in my code here that I had open.
Yeah. So it was pulling whatever the cookie user is. Yeah.
Yeah. And that's coming in from, like, let's say it's KV, so U is now pointing to this, right? Right?
Yep.
And then you're passing that through to the template vars?
So I want to set my template bars as a global so it can go to all my different routes, and then.
But then you have this problem. That's what I thought your question was, which is this problem. Your template vars being global means you've stored KV globally.
In our template bars, we're setting it as. Sorry, just a sec. I need to find it.
That's okay. But do you see what I'm saying? Like, you have a global variable that's an object, let's say, called template vars equals user colon whatever this user was, KV. You now have a global variable that's essentially this, but in an object. And now, here, or even someone else coming here, your template var is set to KV when they may not be KV.
So what we did was we set our template bars as users and then users square bracket rec cookies. So it should be.
You cannot read cookies in here because there's no request here.
Oh, okay.
There's just the application starting up and some global stuff. Anytime a request comes in, which is these little app.gets and app.posts, is where you have cookies, because these handle stuff. So you won't be able to read. If you do rec.cookies there, I don't even know. I should try it out, but like I don't know what that would do.
It sounds like it would just return
Undefined,
undefined.
probably, yeah. Or it would actually rec wouldn't even exist out here. So I don't know how you do rec.cookies here. There is no rec. Rec is inside of your callback function,
Yeah.
right? Hopefully that clarifies that. Yep.
I've noticed that template bars are only included in the render method. So for redirects, they only include like the path. So the redirects go to the get path or the get route, and like so you understand what I mean? Like say if you're say right there it says redirect to.
Yeah, it will do a get. It'll always do a get.
But it goes to the specific like get that's in that we already have defined, right? Like the one above it right there.
Yeah, it'll be get this, which will hopefully we have a route defined, which will be that. We could say get, HTTP google.com, and then it will go to Google. But we're saying come back to our site and its homepage, please.
Yeah.
Right?
Yeah, I just meant like the reason template bars isn't defined there is because that redirect is going up to that get.
Exactly. So the redirect now is saying to this is an important thing to illustrate here. It's not going to be in the recording, unfortunately. But when we do a redirect, we're saying, hey, I'm not sending you back HTML. I'm telling you to go to slash. And so then this person makes a request to slash, which we would hopefully have an app.get to handle. Otherwise, they would get a 404. Did this crappy illustration help a little bit? Yeah? Okay. I'm not done in terms of my agenda. Where was I? We were talking about the treasure, and then there's like login and sign up, but it doesn't have sign up implemented, whatever. And again, this is not an ideal implementation. This is just like minimal, crappy implementation to just get it working with cookies. So here, when somebody tries to log in, we say, oh, what username did they pass up? Actually, let me show you the actual experience first. So here it is. You click login. You type in something. You type in the wrong password. It just says fail, which is not the best user experience, but whatever, which is this else here, right? Here, maybe you would want to actually render the form again and show them an error message. That would be the ideal. That's what you should be doing. I'm not going to give you all my solutions, right? And then, in the success case, what it is the user is found based on the username, and on top of that, the password matches. We do an equality check on the password, right? Because it's not just about the username, it's also about the password. Both of them match because we were able to find the user by username and check the password against the password that was passed up. Now we are confirming that you are logged in. How do we do that? We set the cookie. That's it. Once we set the cookie, we trust that that person is now, it's giving them that temporary pass, and they got to bring it back every time because that's what cookies are all about. And now they can access treasure. So let's try that with KV password 1. And indeed, I'm allowed to see the treasure. It actually is treasure. I don't know what you were expecting there. I said it was treasure. And also, because of my template vars, as I said, this is a function call. Where is it? Treasure. When they make a request to treasure, we send in to that function a value called user, or rather a variable called user, and the variable's data is the user object. Because we don't need all the users, we just need which user is logged in. Right? So far, so good? And of course, that user is used right here. Now, one of the things I do, and I don't know if we've changed our assignment already, because we made a recent update to TinyApp. Does it get you to use locals.user, or is it still just, do you use locals? No. So I suggest this, and we'll probably change that in the next iteration. It's just a little bit more correct and slightly more defensive. So here, it's not just, we could just do user.firstname, but locals is an object. And it kind of helps with the mental model too. Oh, I'm passing in an object. See? I'm passing in an object. And that object is called locals. And so in that object is one property called user. Therefore, I have a property I can access called user. It's more obvious what's happening there. Okay, so if you want to switch anytime you're doing this and you're accessing the template vars, you can just do locals dot the variable name. It'll work just fine. It'll be more obvious or deliberate in terms of what's happening. It's a local variable being passed in as an object. Do you have energy for another 10 minutes? Because I want to go a little bit more advanced now in terms of security. It's going to be interesting stuff that you'll encounter today, but let's see if we can understand it. Okay, so we had a problem that we identified in this file. This was not solved by cookies. Right? This is problem number 1. Cookies can still be manipulated. Can't trust them. They're user data. They cannot be trusted. Right? Either accidentally or intentionally, they can switch it around on us. What do we do? Yep.
In this situation beforehand, we were just using a username to authenticate, so having a password, but password gets sent in the header as well, right?
The password gets sent in the header? No. No, it's just the user ID. User ID could be a number. In our case, it's the username KV. Yep.
So at that point, having a password would be one step towards solving.
I could put 3 pieces of information like user ID, password, I don't know, country, but those are all in the cookies, right? And I mean, I would argue password would be worse because now when I open, if let's say you leave your laptop, I go to your Facebook, which let's say does that, and I open it up, and I open up the application and I see Facebook here for cookies, I would see language, username, and password in clear text. That would be a bigger problem. Right? And here, we can see that I'm just, again, to show that problem, I can just switch this to another user, and yeah, I'm logged in as that user. Right? And so we want to avoid this. How do we do that? We want them to not allow, but they're going to be able to do this with cookies. We want to still use cookies. How are we going to solve that? Yeah. Absolutely. Encrypt the information. Now, before encrypt, there's another step you could have said, which is just make sure it's not like a guessable username. What if it's like some really long random string? Like each user also has a hard to guess ID. Not 1, 2, 3, and we just increment by 1, but like some crazy long string. 32 characters, 64 characters. That's going to be really hard to guess, right? That could be a solution too. Encryption, though, takes it a step further. So encryption would look like this, right? It would just be garbage. And encryption actually solves that problem, but another problem as well. So let's take a step back and let's not implement encryption. And let's say that it was just a random number that we look up in the database. But if you change it, we'll look it up via that number. There's another problem that exists here, which is that I can still guess, right? It'll just take me 1,000 times longer, but I can still guess. When you encrypt it, though, you have no idea what the value inside is because it's been encrypted. So it's not that this string is exactly being used as is. It actually becomes completely encrypted with random kind of characters in there. And that solves another problem, which is I can't tamper with it. I can't change this to some other thing because it's not being used literally. It's actually being decrypted. Then the value is extracted from it, which would be another number or something. And I can't directly access or modify that value. So it solves another problem, which is the whole guesswork piece. Even though it's a long string, I can guess. Well, with encryption, I cannot guess. Okay.
Because no matter what you guess, unless you also have access to the decoding side of that encryption,
Yeah.
will never.
Yeah. Exactly. Now, if I encrypt the cookie, I still have a security problem. Can anybody guess what it is? Where somebody can take over my account. And it has happened in the past. It used to be a big problem on the web. It was solved. Not globally solved with some global implementation, but solved slowly over time. As a hint. There's still a security problem where somebody can impersonate me. How? This is encrypted. Somehow, I'm on the network. I'm accessing Facebook, let's say with an encrypted username, right? Or maybe not Facebook because they've solved the problem, but like some site that hasn't solved it. How can another person impersonate me? Yep. If somebody gets this value, right? How can they get this value? Phishing, yes, they could get it, or they could, open up my DevTools. That's not solved. I could open up your DevTools on Facebook, copy all your cookies, set them as mine, and now I'm logged in as you. That would happen today, I believe. Right? So that's not solved. But even without touching your laptop, I can do it. That's the dangerous part. Not with Facebook, because they solved it, but with other sites that don't implement the solution. How can I, without touching your computer, get this value from you, or without looking at your computer? Yeah. That's a bigger can of worms. Getting access to Facebook's or some website's database opens up a whole bunch of other problems. Like we're trying to secure the communication, right? Not secure the server on the database side. Because that's another thing we'll have to do. That's after we talk about this, I'm going to talk about that. So you're on the next thing already. But what is the difference between HTTP and HTTPS? And why have all sites moved to HTTPS? Security, right? Not too long ago, you would log into like a Hotmail or even a Facebook, I think, with HTTPS. Okay? So that would be secure. My password is being sent up securely. Everything's encrypted. Then they would take me back, and Google had the same problem, to their homepage with my user ID set as an encrypted value. Okay? But now I'm on HTTP. And all my data is flowing through as HTTP, which means that there is a possibility of reading that data. It's not all encrypted. Yes, the value here is encrypted, but I can still read it. And if I can read it, I can copy it. If I can copy it, I can impersonate you. We said I could walk up to you, take up all your encrypted values in here, and still be you, right? And so the problems were coming up where like people's accounts were getting hijacked. Why? Somebody was sitting on the same Wi-Fi listening for HTTP connections, not HTTPS, to certain sites that are of value, seeing all the cookies come through, because you can just see on a Wi-Fi, I can see every traffic that's going through. Now, if it's encrypted, I can't do much with that data. But if it's unencrypted, I can read everything about the HTTP request and response. all the cookies, where did you go, what came back, right? So I just need to be on your Wi-Fi. Or if I have somehow tapped into some of the lines that are physical. So the solution to that was, no, make the whole experience HTTPS, because those cookies, despite being encrypted, can be copied and used to impersonate. They can't be used to guess anymore, but they can be used if I can see you transmitting it over HTTP, I can do the same thing. Do you see that problem? HTTPS says encrypt, keep the cookie encrypted because you don't want them to be able to manipulate it, but then you don't want anybody able to read it, encrypt the whole packet. Encrypt the whole communication on top of that. 2 separate encryption layers to solve 2 different problems. One is guessing the cookie value. Encryption of the cookie solves that. The other is what's called the man-in-the-middle attack, or the person-in-the-middle attack, which is somebody in the middle reading your data, encrypt the whole data. My notes will separate those 2 things out in writing, because right now I'm just talking about it verbally. So if you're not clear on that, you can read those notes. There's one additional problem still. We're not done yet. There's another security problem. Do you see it there? This is no longer about the HTTP, HTTPS communication, but as you alluded to, it has to do with our database. Whether it's like this or a actual Postgres database, as you'll learn about very soon, you know, a more realistic database, there's a problem in how we've implemented our database. What is that problem? The password is stored in plain text, absolutely. So, as you pointed out, if the server is somehow leaked, you know, somebody accesses the server, that's a pretty disastrous event, and gets access to the database, they don't have to do much to be able to get passwords. That's a pretty big problem, and we've heard in the news many different security leaks that have happened. What were some of the recent ones? Sony, I know, was a long time ago, right, with the PlayStation 4 stuff. Was it Yahoo recently? I have amnesia. I am an HTTP server. In any case, there were quite a few breaches recently, and hopefully most of them, if not all of them, didn't store their passwords in this way, or any personal information, such as somebody's address, or their credit card number, and things of that nature. So in the case of passwords specifically, which is such a unique, common thing in applications, what can be a solution? Help me invent a solution. That's crazy. I don't even want to know how many people got fired and what they were doing, how they published the database accidentally. But in any case, I assume that their database had passwords not as clear text. What would they have done? Hopefully, if they were architecting it properly. Any suggestions? We need to be able to compare this value, right? Anytime someone tries to log in. So we need to be able to do that. What can we do with the value? Use a secret key to encrypt the value, perhaps, is the common answer that I hear. And that is a solution that would work, but it is a solution that still has a vulnerability. So I use a secret key, slightly better than clear text, right? I got my secret key, and anytime I'm comparing the values, I say, let's unencrypt the password, and then compare the values that came up from the form that the user filled out. There's multiple problems here. One, if I can hack the server and the code is there, perhaps the secret key is not that far away, because the code is going to need to access that secret key. Now, you can take measures to make sure secret keys are not as readable in case the database does get accessed, maybe not the code, but the database get access, secret key could still be separated and it's not disastrous. But the second problem that you can't solve with encryption is what we forgot to mention here is not only is it that somebody can hack this, but developers have free reign access to this. Or any staff member that has access to the database knows everybody's passwords. And chances are people still repeat passwords, so they can potentially even start being malicious and go rogue and start to like use that information, right? You don't want your staff, when they have access to this stuff, to be able to have access to those passwords. So, but if they have the secret key and the password, some of the developers will have both, potentially, some staff, maybe not developers, would have both, and they would have access. So you still haven't really, you know, you can still, some people in the company can still decrypt the passwords and get access because they'll have the key and the database access. And so encryption doesn't, unfortunately, solve the problem to its fullest extent. It's definitely a step beyond clear text. There's something called a one-way encryption, where you encrypt, but you can never recover the data. Does anybody know what that thing is called? Yeah? Hashing. Hashing is basically one-way encryption. There is no decrypt function. So it's the same key that you'd use to encrypt it cannot be used to decrypt the data. In fact, the data is lost. It's turned into garbage. It's not still in there waiting to be decrypted. That's why it's called hashing and not one-way encryption, because there's no way to decrypt it. Right? And so really what would happen is here, password 1 would just be some garbage. But wait a minute, if we've lost the password, how are we going to sign them in? Can you guess? Yep, Nick?
Same algorithm that like creates that hash done on their password when they enter it.
Exactly. We don't need to know their password. We just need to know what garbage it turns into. And we just compare the two garbage values. Right? Assuming that the hashing function is going to produce the same garbage value. I believe the technical term with that would be what? Like a, I guess a pure function, or I forget. But it would essentially be always returning the same value for the inputs that are passed in. Right? So indeed, this is an algorithm that you can have and that you can use. I'm short on time, so I won't actually demo to you, but you will be using a node library called bcrypt, which uses the bcrypt algorithm to hash values. Okay. Normally, I'd have maybe 5 minutes to kind of show, but not a big deal, because you'll be going through the assignment that actually gets you to implement passwords for users in your Tiny app with that in mind. So the way I've implemented cookies and passwords is actually not how you'll do it. First of all, your cookies will be encrypted. How? You won't be using the built-in express cookie module. You'll be using something called, either it's called cookie sessions or session cookies. I don't know. It's poorly named. And what it will do is it will automatically encrypt your cookie. You'll have to kind of configure it a little bit with the secret key. So cookies will be encrypted. Now, you're not using HTTPS, but hopefully when you deploy your app one day, you'll use HTTPS to solve the other problem, right? Not for a Tiny app. So you've got encrypted cookies. You can't just guess KV or DB. And then on top of that, your password stored in your fake database will be hashed. Cool? That was a lot covered in one lecture, don't you think? I apologize for that. How are we doing in terms of like, we understood most of this enough so that we can at least understand the value proposition of cookies and what problems they still present? Can we do a quick recap? Whoops. Going back to our notes. Remember this one here? Anyone can still impersonate someone else by guessing their username, right? Well, we solved that by encrypting the value. But we also realized that encrypting the value in the cookie still means that somebody could tap into an HTTP connection and copy those and do a person in the middle attack, right? By just reading those values or getting access to the machine, which you can't really, if they have that, you're kind of screwed. But if they can do it without touching a machine, that's pretty bad. And so we solved that by encrypting the whole connection using HTTPS. And that's why a lot of these bigger sites switched, and hopefully everybody has now switched, most people have switched to HTTPS for everything, not just the login communication or the sign-up communication. My notes will go into much better writing than this, so I'll send those out right after lecture. Any questions before I adjourn? Yeah.
It's not related to the lecture, but like what text editors do you use?
I'm still stuck with Sublime. Actually, I use all three. I use Sublime, VS Code, and actually I've switched off Atom for the most part. For different projects, I use different editors because I find that they're so transferable. Like I'm not trying to be a master with all the shortcuts on one, and the shortcuts that are relevant to me are actually shared across all of them because they try to compete with each other. So I use all three depending. So for lectures, I use Sublime. I've switched over VS Code for like non-lecture stuff. I find VS Code sucks for lecture because it breaks up the screen too much. And then if I do Command plus to zoom in, it like zooms in everything because it's kind of a web browser technically. And that's just the way they've decided to implement it. And so I don't like that when I do Command plus, everything gets bigger and my text area gets smaller. So that's the reason I've stuck with Sublime for lecture. Dawn uses Vim. And I like that different lectures use different editors on the screen because you get to at least get a preview into what you could one day learn. But do not get too caught up in the editor coolness race. You know, yes, it'd be cool if I could use Vim, but I don't want to invest hundreds of hours trying to learn it. Right? That's my opinion anyway. Cool? Any other questions? Yep.
I have looked at some hashing stuff, and I am a little confused about how adding salt to your hash absolutely does anything.
Yeah, so great question. Has to do with hashing and salts, which we haven't even talked about here. This is a pretty deep topic. Like there could be, a university degree on cryptography, and hashing would be at least a few courses worth of information. Of course, for us, we care about being able to use these and understand them at a conceptual level, not from a cryptographic math perspective. What I'll say about this is you can use the bcrypt algorithm without fully understanding it because it is pretty crazy math stuff happening in there, and kind of read the documentation to understand sort of the high level. But if you still have questions about, oh, what is the salt for? What is the value of the salt actually being in the hashed string that I'm storing in the database? What the hell are rainbow tables? All of that stuff is like advanced questions out of the scope of the bootcamp. But you have mentors, and you can ask them for help, and maybe some of them will be able to answer it, some of them won't. So I encourage you to research some of that stuff on your own and or with your peers, and then see if you can answer that. And if not, feel free to come back to me in a week or something like that. Cool beans? Okay, I'll leave it there. Cheers, everybody. Enjoy.